Hey, good morning, class. Good morning, everyone. How are you all doing? Good morning, everyone. Hello, and one more hello. Good morning, everyone. Be quick. Be quick. Get settled. Great. Good morning. Good morning to all of you. All of you. Good morning. So let's begin the class, Anna. And today we'll discuss the energy, the most important concept, Anna, of Bohr's atomic model, the energy part. Come on. So write down energy. We have discussed the radius in full flow. Let's discuss it now. Energy. So we'll simply write down first the formulas which we are going to use it. Indra Karan, Bose, Gujala. Okay, it's okay. I mean, focus over here. Come on, over here. We can do that later on. The classes begin. So let's focus on Chalwaja. So I'm going to give you certain formulas. The derivations are not important as of now, but their application is definitely. So we'll be working on the application part. Now, please pay attention. The potential energy, and all this is valid for one electron species. For one electron species. See that? So potential energy is given as minus of K Z square upon R, where R is the radius, K is a constant, Z is the atomic number. Okay. So also kinetic energy is given by K Z square upon 2R. Okay. And total energy En is given by potential energy plus kinetic energy. Now this thing is actually equal to minus of K Z square upon 2R. All these formulas are extremely important, and we will be doing some questions on them as well as a result of direct application. No, that will come, Vijay, that will come later on. But first, let's do some questions, because in your module, there are certain questions which are basically based on all this. Okay? Shall we begin? Come on. I'll tell you one thing. Can I say that potential energy is twice of total energy? True or false? True or false? Keep on observing out there and keep on giving the answer. Is it true that potential energy is equal to twice of total energy? Come on. Yep. Very good. Very good. And whatever I'm writing is true. So just keep on saying true. Okay. I'm not taking a test as of now. Keep on saying true. All that are correct. Chalo. So can I say that, potential energy is also equal to minus of 2 into kinetic energy? Can I say that? True or false? True or false? Arey, wow, very good, Zamir. Very good. Can I say that En is equal to minus of kinetic energy? All these things will go a long way in helping you to solve multiple questions in a go. Okay. Acha. Again, one more thing. Can I say that if radius will increase, potential energy will increase? True or false? Potential energy will increase. True or false? Jaldi karo. It is true. All of that I'm writing is true. So keep saying true. Arey, no. Arey, Evangeline, it is true. Everything is true. Dinesh, true evo. Because there is a negative sign. There is a negative sign. If there was no negative sign, it will keep on decreasing. But because of negative sign, it will keep on increasing. Are you getting it? Dinesh, is that okay? Okay. So, and what happens to total energy? I think this will also increase because it also has a negative sign out there. But kinetic energy will decrease. Yes or no? So keep these things in mind because there are many questions on that stuff, hai na? Okay. Chalo, let's do some graphs now. Come over here. So first of all, kinetic energy, which is equal to K Z square upon 2R. So boys and girls, tell me, can I say that kinetic energy is proportional to 1 by R? Can I say that? Acha, can I say that? Acha, since I know that, I also know that R is proportional to N square. R is proportional to N square. So can I say kinetic energy is proportional to 1 upon N square? In place of R, put N square. Okay? Okay. Also, I believe that acha, they will be straight line. They will be straight line. Y is proportional to X will give you what? Always a straight line. Acha, also I can say that if I take R over there, kinetic energy into radius. Now, if I take R there, K constant, Z constant, E constant, and this 2 also constant. So this will give me a constant. Yes or no? And also I can say kinetic energy into N square will also be a constant. Yes or no? If I take it there. So whenever we have got a graph like x into y constant, y into x is constant, this kind of graph are always what? Rectangular hyperbola. Rectangular hyperbola. Yes or no? Very good, bachche. Zamir, very good. Brilliantly good. Is it okay now? So the first two equations are an equation of straight line. Y proportional to x is always a straight line, but y into x is always a rectangular hyperbola. So shall we plot graphs? Come on. If I have got, say, kinetic energy over here, and this is 1 by r, the graph will be straight line. Go there right now. So kinetic energy again, and this will be 1 by n square. Again a straight line. But if I have got kinetic energy on the y-axis and r out here, radius out here, it will be a rectangular hyperbola. Similarly, I can also have kinetic energy and n square there. It will also be a rectangular hyperbola. Yes or no? Be quick. Be very quick. But just learn these graphs. They are extremely important. In your module, there are a few questions on that also. So it will help you out there. Okay? Chalo, come over here. Now let's have energy. Energy is minus of K ZE square upon 2R. So can you say this is negative? This is negative. So can I say that En is proportional to minus of 1 by R? And can I say En is proportional to minus of 1 by N square? Okay? These will be straight line, and if I take it there, En into R will be a minus of constant. A negative value will be there. And similarly, En into N square will be again a minus of constant. Will you agree? And they are nothing but again what? Y into X equal to what? Constant. This is a rectangular hyperbola. So shall we draw some graphs now? Shall we? Now come over here. This is a negative value, negative value, negative value, negative value. Energy is always negative. Okay? Chalo, aajao. Come over here. So I'm having this graph now. This is En and this is 1 by R. So energy will be negative with a negative slope. Negative slope is like this always. Yes or no? Acha, can I extend the graph like this? This is En, this is 1 by R. So can I extend the graph like this? Can I extend? Can I extend the graph? Come on, boys and girls, be quick. No, I cannot extend that. No, we cannot do it. No, we cannot do it. The reason is that over here, this part, 1 by R will be negative, and radius is never negative. Radius is never negative. Are you getting it? So this part is not allowed at all. This thing is not allowed. So these part of the graphs are not allowed. Are you getting it? Radius is never negative. Done? Okay. So here we go. How about this one? How about this one? En over here and 1 by n square. Again a negative slope. Again a negative slope. Okay, now come. One more. Come on. This is En and this is what? R. R. So it will be a negative rectangular hyperbola. This is the negative. Negative. And this energy is always negative. Energy is always negative in the bounded state. And out here, En and n square. Again a rectangular hyperbola. Again a rectangular hyperbola. Yes or no? Acha, will you agree with me if I tell you, that the graph of potential energy will be same as that of En? Can I say that the graph of potential energy will be same as that of En? No, potential energy is also negative. Potential energy is also negative, beta. See that? Both are negative. This is negative, this is negative. And formula is almost same. Only 2 is there, which is also a constant. Which is also a constant. Yes or no? Both of them. See that out here, potential energy is proportional to minus of 1 by r, and En is also proportional to minus of 1 by r. Agree or not? Agree or not? So they will give you almost similar graph. Similar graph will be there. Like there are 3-4 questions in the module, and chances are there they will ask you basically in the exam also. Okay? Chalo, come now. Okay, here we go. Now, having done this thing, so I told you a formula basically for radius. Remember that Rn is given as, boys, n square h square upon 4 pi square m k z e square. So this formula will enable you to find out the effect of mass and charge on the radius. But the formula which you learn, 0.529 into n square by z, this formula does not give you any idea about the effect of mass and effect of charge on the radius. Similarly, I'll tell you one more formula for energy also. This En is given as minus of 2 pi square m k square z square e to the power of 4 upon n square h square. So remember that this is a negative sign out there, and if the mass is doubled, what will happen? What will happen to total energy? It will double, but in negative direction. In the negative direction. Suppose earlier the energy was minus of 4, now it will become minus of 8. Now it will become minus of 8. Exactly. Okay, good, very good. And if the charge doubles, then what? Charge doubles. It becomes 16 times. It becomes 16 times. Yes or no? No, 16 times, beta 16. 2 to the power of 4. E to the power of 4. 2 to the power of 4 is 16. 16 times. Vijay, got it? Okay, look. Okay, here we go. And is that so? So can I say En is proportional to minus of z square upon n square? Because generally they will change the value of z and n only, but m and e will remain same. Okay? So a question for you people. Find the ratio of E1 of hydrogen is to E1 of helium plus is to E1 of lithium 2 plus. Can you find the ratio? Can you find it? चलो, कार्तिक पप्पाला MBBS तो बाद में मिलेगा, पहले सवाल तो करो. 1 1 1 energy of orbit number 1. Can you see that over here? Since n is same, so energy is proportional to what? Z square. Energy is proportional to z square, है ना? So it will be proportional to 1 square is to 2 square is to 3 square. That is 1 is to 4 is to 9. 1 is to 4 is to 9. Getting it? All of you? Very good. Acha, chalo. Now one more question. Just one more question. Tell me one thing. Find ratio of E1 of hydrogen is to E2 of helium plus is to E3 of lithium 2 plus. Come on. It is all valid for single electron species. We are still discussing Zamir Bohr's model, which is applicable only for single electron species. Come on. Yes. Now E both are changing. Orbit number 1 and Z both are changing. So I believe that E is proportional to Z square upon N square. So Z is what? 1 square. N is also 1. 1 square. Here, come on. Z2, 2 square. N also 2 square. 3 square and 3 square. They will cancel up, and 1 is to 1 is to 1. So can I say, beta, that energy of orbit number 1 of hydrogen is equal to energy of orbit number 2 of helium plus? But revise them multiple times, because there are many questions which will be based directly on these things, directly on these results we are getting right now. Getting it? बहुत ध्यान से करना बच्चों. You will have to revise multiple times, है ना? You have to revise it multiple times. चलो ठीक है. Okay. Having done that stuff, okay, now let's do a formula which will be very useful for us, है ना? So for one electron species, we are giving this En is given as minus of 13.6 into Z square upon N square. When we'll put those values, we'll get this value, and this will be electron volt per atom. Boys and girls, please remember that unit. This is per atom, electron volt per atom. And then we have got En again in format of minus of 2.18 10 to power of minus 18 into Z square upon N square. Now the unit is joule per atom. This is joule per atom, okay? And En is also, once, I mean, NEET asked this question, same question, they gave the multiple formula of energy and they asked which formula is correct, है ना? So this was 11312 into Z square upon N square, and this time it is kilojoule per mole of atom, okay? And one more formula is there, bachcho, and that is En equal to minus of 313.6 Z square upon N square. This is kilocalorie per mole again. Be careful with that. All these formulas, they're extremely important, very, very important. And bachcho, please just take one advice very seriously. Keep on doing NCERT line by line. It's very important right now that you're doing and hunting the entire NCERT. Getting it? That will make your chances of selection even very high. Getting it? Good one. Come on. Very good. So shall we? Now I'll be focusing on this thing, bache. I'll be focusing on this thing. Come over here. See, like say En is given as minus of 2.18 10 to power of minus 18 into Z square upon N square. And that is what joule per atom. But you see that for hydrogen atom, this RH value is this given as 2.18 into 10 to power of minus 18. Are you getting it? This will be joule. So for hydrogen atom, this formula will become minus of RH upon N square. Are you getting it? And the energy will be joule per atom. So if you are doing some other books and other modules, you will find a question, a very famous question they ask you, that what is the value of the RH? What is the value of RH for helium plus? So remember that for other one electron species, this RH is given as what? This RH value will be given as what? This will be given as 2.18 into 10 to power of minus 18 into Z square. Yes or no? So suppose they give you a question. that RH for hydrogen is say X. Then find RH for helium plus. Come on, find. The answer will be multiply that by Z square. It will be 4x. And they ask you find the RH for lithium 2 plus. Will be how much? Come on, everyone. For lithium 2 plus, 9x. It will be 9x. Multiply by Z square. And bachcho, please keep on revising. I'm again repeating, bachcho, keep revising. It's very important that you do the revision properly. Practice them multiple times. Your chances of selection will go very high. very, very high. Okay, shall I? Okay, come on now. That part done. Now, bacho, we are going to do certain formulas, certain values. If you really want to command Bohr's model, and that too in the fingertips, learn these values. Otherwise, handling Bohr's model will be a very, very tough task, especially in the entrance examination. Okay? Chalo, aa jao. So this thing is now for hydrogen atom only. Hydrogen atom only. We're discussing this for hydrogen atom, na? So remember certain values, beta. Remember certain values I'm giving you. Say this is orbit number 1, this is orbit number 2, orbit number 3, orbit number 4, and orbit number 5, and so on, and orbit number infinity. But you all know that energy of orbit number 1 in hydrogen atom is actually minus of 13.6 electron volt per atom. Agree or not? And minus of 3.4 electron volt for second orbit. For third orbit, minus of 1.51 electron volt, minus of 0.85 electron volt, and minus of 0.54 electron volt. Learn these values. They're damn important. Very, very important. And you will see that in the next lecture, I'll be solving almost all the questions almost verbally with the help of these values. Your hydrogen spectrum and your Bohr's model will be under a command if you handle this thing properly. Please learn these values. They're extremely important, extremely important. Are you getting it? And not only this, but please learn that the difference of energy between orbit number 1 and orbit number 2 is 10.2 electron volt. E2 minus E1, delta E. The difference of energy between second and first orbit, delta E is what? E2 minus E1. This will be 10.2 electron volt. Very good. Who will tell me? Acha, infinity. Infinity will be 0. Very good. At orbit number infinity, it will be 0 electron volt. It will be 0 electron volt. Very good. So can you see that the energy is increasing from minus 13.6 to minus 3.4? The value is increasing and it becomes maximum at orbit number infinity. And the value is what? 0. Yes or no? This gap is 1.89 electron volt. ये बहुत important है बच्चों, very, very important. 1.89, and this energy gap between E4 and E3 is 0.66 electron volt, and this one 0.31 electron volt. Please better learn these values. I mean, they will help you in propelling you on a higher rank. You will save time, the confidence will grow, and you will also know that the time taken by the other students in handling these questions will be too much. Okay, very good, very, very good, bacho, very good. Learn these values, because in the next lecture we will be doing many questions based on these only, beta. Okay, not only this, bacho, just one additional task, just one more additional task. And what is that? Beta, E infinity minus E1 is how much, beta? 13.6 electron volt. Okay, E5 minus E1 is 13.06 electron volt. E4 minus E1 is 12.75 electron volt. E3 minus E1 is 12.09 electron volt, and E2 minus E1 is 10.2 electron volt. But please learn these values. They're extremely important. There are questions which you cannot solve if you don't learn these values, because otherwise you will have to use a difficult formula with difficult values, and it will steal a lot of your time, which we don't have. Time is the luxury in the entrance examination, okay? And we don't have that. Learned? Have you learned that values? 13.6, 13.06, 12.75, 12.09, 10.2. These values are extremely significant, okay? Okay. You will see the magic of all these things once I tell you that stuff, hai? For example, bacho, they can say that in hydrogen atom, if this is orbit number 1, this is orbit number n, and this electron is out here, a photon comes of the energy 12.09 electron volt, 12.09 electron volt, where it will go? Come on. Where it will go? 12.09. It will go to what? E3. Very good. This will go to orbit number 3. This will be orbit number 3. And if I change it to, like, say 12.75 electron volt, where it will go? Where it will go? Orbit number 4. Are you getting it now? Now it will go to orbit number 4. And now they can further ask you questions. They can further ask you that when the 12.75 electron volt energy is supplied, electron reaches orbit number n. Now how many total lines can be formed? How many total lines can be formed when it will fall back? Total lines formed will be, beta, what? Come on, total lines. 4 into 3 by 2 equal to what? 6. Yes or no? Total number of lines formed is n into n minus 1. N into n minus 1 upon 2. They are the total number of lines. Yes or no? So any question they ask you, I mean, if you suppose you do not know this thing, you do not know, but it will be a very difficult task to handle that question. Yes or no? Because the only formula which is available for you people will be delta E is equal to 13.6 into Z square 1 upon N1 square minus 1 upon N2 square. Oh, this too will be very difficult now. Extremely difficult. Are you getting it? This way you will get the answer in an instant. In an instant. And it will empower you. Yes or no? Come on, boys and girls. Jaldi bolo yaar. Don't underestimate the power of a common man. And don't underestimate the power of these values. Getting it? Yes or no? बोले नहीं रहे तुम लोग यार, चुपचाप बैठे हो. Hey, are you studying or sleeping or something else is going on? चलो. Okay. Okay, here we go again, bache. Okay, that is done, commanded. And will you keep on writing the answers very quickly? Come on, tell me. E5 minus E1. Be quick. E5 minus E1. E5 minus E1. Come on. Do you think that this is like going to be 13.06? E4 minus E1, 12.75. E3 minus E1, 12.09. And E2 minus E1, 10.2 electron volt. Yes or no? Very good, brilliant, very good बच्चों, अच्छा कर रहे हो यार, करते रहो ऐसे, याद करो उसको, learn that stuff. अच्छा, now one question, and now you will be able to understand one thing. Boys and girls, see that this is orbit number 1, orbit number 2, orbit number 3, and orbit number infinity. Energy is here 0 electron volt. Here it is minus of 13.6 electron volt, minus of 3.4 electron volt, and minus of 1.51 electron volt. Tell you one thing. If an electron falls from 2 to 1, it will emit a photon of energy. How much, beta? 10.2 electron volt. 10.2 electron volt. But if an electron falls from orbit number infinity to orbit number 2, it will also emit a photon. But the energy will be how much? How much energy will be there? Maximum energy possible is what? 3.4 electron volt. 3.4 electron volt. Yes or no? What I am saying is that for Lyman series, this is the minimum energy difference. And for Balmer series, this is the maximum energy difference. Maximum. But still, the minimum energy of Lyman series is almost 3 times the energy of the Balmer series, which is maximum right now. Maximum energy of Balmer series is 3.4 and minimum energy of Lyman series is 10.2. Yes or no, beta? Yes or no? अरबाज यार फोकस करना है इधर यार. Okay. That's why these lines are very energetic. You can see the difference, beta. You can see 13.06, 12.75, 12.09, 10.02. In the Lyman series, energy value is very high. That's why they lie in what? Ultraviolet region. Ultraviolet region. Yes or no, beta? Thank you so much. Thank you, बच्चों. Thank you. ठीक है? Is that okay? And if we come over here and if we go to this thing, the maximum energy level, the maximum, अरे तुम इधर देखो पहले यार, तुम लोग कहां तुम कर इधर इधर इधर. The maximum energy level for this Paschen series is how much? 1.51 electron volt. This is very less, very less, बच्चों. Yes or no? And this will lie where? This will lie basically in what? Infrared region. Infrared region, बच्चे. Okay. And if you keep on moving further for the bracket series, fund series, the energy difference will keep on decreasing. Energy difference will keep on decreasing. बच्चों, see, देखो यार बच्चों. Look. Give me a look. कहाँ जाऊँ मैं? किधर चला गया? See that? As I keep on moving away from the nucleus, the energy difference keeps on decreasing. Yes or no, beta? Yes or no? So can I say that over here? Can I say that E2 minus E1 is less than? Sorry, my mistake. Is more than E3 minus E2 is more than E4 minus E3 and so on. Yes or no? The energy gap keeps on decreasing, but with respect to radius, R2 minus R1 is less than R3 minus R2 is less than R4 minus R3. Remember that from the last lecture? The gap between the radius, consecutive radius, keeps on increasing, but the energy keeps on decreasing. But remember that this is 10.2. This is what? 1.89. This is what? 0.66, 0.31, and so on. And this was, if you remember that, this gap was 3x, this was 5x, this was 7x. Remember that or not? बच्चों याद करना यार, please keep revising that stuff, है ना? Otherwise whatever we are doing will get lost. The radius gaps keeps on increasing, energy gaps keeps on decreasing as we keep on moving. Okay, good, very good बच्चों, extremely good. आजा बच्चों. So that part we have done. Okay, now see that. Everyone look up. En is equal to minus of 13.6 into Z square upon N square electron volt per atom. Okay. Now what is E1? Minus of 13.6 into Z square upon 1 square. And 1 square means nothing but 1. So E1 is what? Minus of 13.6 into Z square electron volt. गले की बैंड बज गई यार, ऐसे बता रहा हूं. I mean, the maximum energy I'm putting is in your batch. In the other batches, so I do have student in front of me, so they are able to communicate. But what happens, since you are not there, and I am a kind of teacher who do a by-way kind of teaching. You respond, I teach. But over here, like there is no one. So I think that I should be putting more energy, and then you will give me back energy. But energy is coming back, but in terms of this, what do you call that? Chat. But I believe that human beings cannot be replaced by any kind of this chat kind of thing. You are in Lyman series, sir. Highly. Arey, this energy is coming from you people, bachcho. Trust me. Definitely we have to bounce back. We have to bounce back. यार एक इंद्रकरण बोसे, बेटा आप क्या लिख रहे हो? This is Telugu and I do not know Telugu. Can you write down English? Are you doing some code word kind of thing with Sharanya? Both of you focus over here. Okay, chalo. Love you too, bachcho. But I mean, right now we have to focus out here. Focus over here. Chalo. Come. Both of you come on. Focus over here. So this is E1. But what will be E2 if we go with this formula? Minus of 13.6 into Z square upon 2 square. And what is this thing? This is actually E1. This is E1. So can I say E2 will be E1 upon, sorry, 2 square. 2 square. Similarly, can I say, boys and girls, this will be minus of 13.6 into z square upon 3 square. And what is this thing? What is this thing? Bolo bachcho. E1. This will be E1 upon 3 square. Acha, ek baat batao. Can I generalize now? Can I generalize? En will be E1 upon n square. Can I say that stuff? And this is extremely important. Okay. Achha, remember that I told you Rn will be R1 into n square. So beta, please keep comparing. Keep comparing. This all will be required when they will ask you to do some analytics out there. Rn equal to R1 into n square and En equal to E1 upon n square. Good one. Very good. Very good. Very good, bachcho. Come on. Can we move ahead now? Okay, dekho. One more thing, bachcho. See that stuff. See orbit number 1, orbit number infinity. And this is minus of 13.6 electron volt for hydrogen and electron volt. This is 0 electron volt. So if the electron is in orbit number 1, the amount of energy required to send the electron from orbit number 1 to orbit number infinity is how much? We call that energy. What is that energy called? That is called ionization energy. Yes or no? The amount of energy required to send electron from orbit number 1 to orbit number infinity is called ionization energy. So this value will be, I believe, 13.6. 13.6. Yes or no? And what is this thing? This is actually equal to, this is what? E1. This is E1 and this is IE. So can I say that this IE is equal to minus of E1? Will you agree with me or not? Will you agree? That IE is equal to minus of E1. Good, very good, brilliant. Very, very good, bache. Suppose 1 and orbit number infinity. This is minus of 50 electron volt. This is 0. Amount of energy is called ionization energy in this case. How much? How much? 50. It will be 50. Very good. Whatever the value is of E1, make it of opposite sign, positive value. So boys and girls, we are writing that IE will be equal to minus of E1. Minus of E1. Yes or no? And if I go with the formula, that IE, you know that E1 is what? Minus of 13.6 into Z square. So IE will be how much? 13.6 into Z square. All these formula will come to your help later on. All of them. Okay? Good. Very good. Very good. Acha, now see that. See that if this is N1 and this is say N2, this energy gap is called delta E. Is called delta E. So delta E will be En2 minus En1. So when you put the values, you will get 13.6 into Z square 1 upon N1 square minus 1 upon N2 square electron volt. Yes or no? We'll be using all of that, bache. We'll be using all of that in a short while. Here we go. Achha, over here, can I write down, if you allow me, can I write down that delta E will be, this is what? IE. IE into 1 upon N1 square minus 1 upon N2 square electron volt. They can give you anything, but they will be asking you to help yourself with the common sense. Okay? So shall we move and do some questions now? Shall we? Okay, here we go. Can I? Okay. Chalo. Okay, see now. Be very careful. I'm giving you IE is equal to 640 electron volt for a 1 electron species. Okay. And I'm also giving you that En is given as minus 40 electron volt. They're saying find N. Find the value of orbit number. Find the value of orbit number. Come on, be quick. Fastest, fingers first. जल्दी करेंगे, त्वरगा। No, I'm asking En. I'm asking En. Zamir, I'm not asking E1, I'm asking En. E1 is correct, but I'm asking N, orbit number. For which orbit number we're talking about? Yep, Zamir, correct. Correct, Zamir. Very good. So I believe from IE, I can find out E1. E1 will be minus of 640 electron volt. है ना? And once I know E1, I can find out En also. What is that? En will be equal to beta E1 upon N square. Or you can say N square will be E1 upon En. E1 is how much? 640 negative. And En is minus of 40. Minus of 40. So this will be cancelled, gone. This will be 16. So N square is 16. N will be 4. We are in the fourth orbit. They're talking about fourth orbit, bachcho. Yes or no? We're talking about fourth orbit. Okay, one more question. And this is a good question. This question will check that whether you are revising or not. Okay? Chalo, tell you one thing. Question says that IE is given as 81 electron volt, and they are saying, what they're saying? Find second excitation energy. Find second excitation energy. Come on. Find the second excitation energy. This is a good question. Try it seriously. Come on. Second excitation energy. No. देखो ऐसा नहीं. See. I believe that you should know first what is excitation energy. What is excitation energy? Perhaps I believe that Ruchi is giving the correct answer. Perhaps somewhat like that. Evangeline also giving the correct answer kind of thing. Vagdevi has given the correct answer. Very good. Very good. Rest of you are giving me some other answers. You are giving me basically, I believe, okay. See that. Beta there देखेंगे आप लोग, please everyone. First, second, third. The energy required to send electron from orbit number 1 to orbit number 2 is called first excitation energy. From orbit number 1 to orbit number 3 is called second excitation energy. Yes or no? So if I'm looking at orbit number 1 and orbit number 3, this is the amount of energy which will be called second excitation energy. That is called delta E, which will be equal to what? E3, and this is the E1, will be equal to E3 minus E1. Yes or no? Second excitation energy. The energy required to send electron from orbit number 1 to orbit number 3. I'm not asking the energy of second excited state. No, I'm not asking that. Yes or no? Okay. This question is not saying find the energy of second excited state. They're saying second excitation energy. The energy required to send electron from orbit number 1 to orbit number 3. So I believe from here I can say E1 will be minus of 81 electron volt. Yes or no? And once I get that, this is like say 1, this is 3. So E1 is how much? Minus of 81 electron volt. Beta E3 will be how much? E1 upon 3 square. E1 upon 3 square, and I believe that will be how much? Minus of 81 upon 9 is equal to minus of 9 electron volt. Minus of 9 electron volt. Minus of 9 electron volt. Yes, very good. And then delta E, this is delta E, will be, come on, E3 minus E1. Minus of 9 minus of minus 81 will be equal to minus of 9 plus 81. And this will be equal to 72 electron volt. You will be supplying 72 electron volt for electron to go from orbit number 1 to orbit number 3. Is that clear? Is that clear? We have to make sure that which formula we are going to use, but please try to find out the shortest possible way. For that you will need some practice, and well, you will practice now, you will able to connect the different formulas, and over the period of time you will also come to know that which formula to apply and which not to apply. Many times students ask me, sir, we know the formula but we do not know which formula to apply when. So it will all depend on the practice part. So keep on doing practice and this problem will dissolve automatically. Okay? Yes or no? Okay. Chalo. One more question. One more question, bachu. Come on. This question says, we have got, okay. Z is given as beta 5, N1 is given as 3, N2 is given as 4. They're saying find delta E. Find delta E. You can give me approximate answer, bachcho. You can give me approximate answer because in NEET, normally the options are not very close. Once in a while, they give you one question in 3-4 years, hai na? So which can be handled. Moreover, now these kind of questions will be coming in section B. So we can opt out of it. Hai na? We won't attempt it. We'll attempt something which is simple and which is scoring. Come on, delta E. Give me an approximate answer. And I'll teach you approximation also here. Dekho, see, delta E is equal to 13.6 into Z square 1 upon N1 square minus 1 upon N2 whole square. Hai na? So this is 13.6 into Z square 25 1 upon 9 minus 1 upon 16. This will be 13.6 into 25 into 7 upon 144. But shall I share art? Ha, very good, bache. Zamir Sheikh, very good. Ha, correct, bache. Rutvika, very good. Very good. Approximately, we'll do it. Very good. Okay. Now, bache, what I'm saying, I'll teach you something. How to do approximation. Remember, first trick. Don't touch a small number. Sharanya, very good. Don't touch a small number. I mean, you can't put 2 as 1 or 2 as 3. No, that will be dangerous. But bigger the number, you can make approximation. Bigger the approximation. Smaller the number, smaller the approximation. And very small, oh, don't touch it. Don't touch it. Yes or no, beta? Okay, so for example, what I will write down, help me out since you're my student. This 1937 can be written as what? Can be written as what approximately? Can I write down 2000 approximately? Depending on the case. Okay, come on, tell me. 98. I believe I can write down 100. I can write down 100 or not? So bigger the number, more the approximation. Yes or no? And we have done that thing. Remember that 96500. I will writing like 9600. Remember that? So bigger the number, bigger the approximation you can take. Okay? Now come over here. Now see, just like you people, my maths is very weak. So if you allow me, can I write down 14? Can I? 13.6 isko aata yaar. Thank you, Indrakaran. Okay. So this is 25 and 7. Acha, what do you want me to write this thing? 140 or 150? 140 or 150? You let me know. 140. Ananya, how will I write 140 beta? I do not know table of 25 and N to 140. I'll write 150. Oh boy. I'll write 150. You can choose 140, 150. Ek hi baat hai yaar bachcho. But 150 will give me an edge 6 times. And now don't approximate 7 and 6. Don't do that. Leave add it. And this will become 14 7s are 98. And this is say 6. So 16 6 are 96. 16 6 are 96. Will be approximately 16.6 kind of thing or 16.5 kind of thing. Approximately. Yes or no, bache? Getting or not? 14 cancel. 14 kaise karega? 7 into 14 is 98. Venkat. Achha, the options in this question, but the options in this question are a bit different. Hai na? Like, kaise hai? Like, first option is 3 point something. Second option is 81 point something. Fourth option, the third option is say 17 point something, and fourth option is 32 point something. So which option you will opt for? Acha, okay. Venkat, you can do that also. Okay, you can do that also. You can do that also. But for me, then again, this will become a trouble for me. Are you getting it? You can do that also. Still, I mean, your answer will be fine, Venkat. Are you getting it? Okay. Chalo. Oh. Come. एक और क्वेश्चन करेंगे बच्चों. One more question. Question says delta E is given as 47.3 electron volt, N1 is 2, N2 is 3. They're saying find Z. Find Z. And remember that Z cannot be decimal. Z cannot be fractional. I believe if you get the value of Z while calculating 4.8, so what value you will put? If you're getting value of Z as 4.8, what value you will put? Come on. 5? The nearest possible integer is 5. Acha, 4.1. If you get 4.1, then what? You will put 4. Go for the nearest value because the Z value cannot be fractional. Okay? Come on over here. We will try this also. Come on. Delta E is equal to Z square. Sorry, 13.6. 13.6 into Z square, 1 upon N1 square minus 1 upon N2 square. So this is 47.3 equal to 13.6 into Z square, 1 upon 4 minus 1 upon 9. Okay, it's 47.3 equal to 13.6 into Z square, 5 upon 36. 5 upon 36. Yes or no, beta? Now I believe that 5 upon, चलो करते हैं इसको जरा देखते हैं. Z square will be 47.3 into 36 upon 13.6 into 5. So if you are a bit careful, but approximately, beta, can I say this is 7? Can I say this is almost 7? Come on. And now this is 47.3. So 47.3. 47.3. What do you want me to put 47.3 as? Come on. 47.3. Come on. Can I write 50? Can I write 50? Good one. 50 into 7, and this is what, beta? Can I write down 14? Can I write down 14? 13.6, 14. 7, 2s are 2, 25. So Z square is equal to 25. But yes, Z is 5. Z is 5. Don't say approx, Vijay. Z will be 5. Because 5.1 or 4.8, anyhow it will be 5. Find out the nearest integer. Find out the nearest integer, bache. Yes or no? Even if your answer, if you're doing exactly, you will get, like, say, Z square as 23 point something or 24 point something. So take it to the nearest square of any number. That is 25. Yes or no? Okay. Just one question coming up. One last question coming up. Okay, I'm giving you for hydrogen atom. For hydrogen atom, bacho, if I say potential energy is given as minus of 1.08 electron volt. Find orbit number. Find N. Find orbit number. Now you will see the magic of what you have learned earlier. Those values, they'll help you like hell. Come on. Come on. Which orbit I'm talking about? This is the hydrogen atom. Potential energy is minus of 1.08. See, I know one thing. En is potential energy by 2. Potential energy by 2. Sharanya, earlier you were right. Okay, so this will be minus of 1.08 upon 2 equal to minus of 0.54 electron volt. Yes or no? Now, minus of 0.54 electron volt belongs to N equal to 5. This is the energy of orbit number 5. Remember that? If you don't do this thing, bachcho, you will have to do a lot of calculation unnecessarily. Orbit number 1, minus of 13.6, minus of 3.4, minus of 1.51, minus of 0.85, minus of 0.54. Learn these values. Learn these values. They'll help you a lot. We're in orbit number 5. Yes or no? 1, 2, 3, 4, and 5. And they won't ask you beyond it. They won't ask beyond it. Okay? Chalo bachcho, the class is over right now for a day. I'll catch you next time. But bachcho, before coming to the class, please revise all these values, because next lecture is an application of what we have learned today. Yes or no? Bye-bye. Bye all of you. You guys are hero. I'm not hero. You guys are hero. Chalo, bye-bye. Bye-bye. Bye. All the best. Take care. Keep smiling. So much. Thank you, everyone. Bye-bye, bachcho. Bye. God bless you all. Bye-bye. Bye-bye.